Hello, in this video we will discuss about a couple of features which is listed here. We will discuss about data sources, we will discuss about the count for each functions and dynamic function. So let's get started. Let's talk about the data sources first. Data sources are used to query the data from the various resources. For example, if you need to get image information to create a compute instance VM, such as Debian 9 or Ubuntu 1804 or any of your custom images, you can use data source query to get the image information and can use that in compute instance resource block in the config file. Data source block is declared as data followed by the resource you need to query. For example, Google Compute Image as in the code block here, followed by the name of your choice. In this example, Ubuntu Image. Inside the block, you need to provide the filter criteria for the resources. In code here, family and project are mandatory arguments. Based on these arguments, data source query will return various attributes of required resource. Similarly, other resources will have their respective filtering, mandatory or optional parameters. Data source return value can be used similar to following ways. Like listed here, an image value can be assigned by referencing data.googlecomputeImages.ubuntuimage.selflink. Similarly, suppose network IP need to be referred of a VM, we can get this data from data.googlecomputeinstance.mysql VM. For example, VM name if we have defined as MySQL VM in Terraform config.network IP. When you execute Terraform plan or apply, Terraform will execute the data source query and fetch information from the queried resource. If information will get available after resource are created when you run Terraform apply, in that case, reading from data source will be deferred until the apply phase. More details can be found in the given link here. GCP data source can be found in the given link here. Look for Google Cloud Platform data sources. I'll provide these links in the description box. So let's do the hands-on of the data sources. So I am in a directory called P4. In that, I'll create another directory called data source. In this directory, I'm going to create my Terraform configuration. I'll copy a couple of blocks from the common which I have created here. So I'll copy the provider block from here. As well, I will copy this var_gcp file from common block. Okay. So this file just contains my Terraform service account JSON and the project name. I'm going to copy the rest of the code also. Google Compute address will generate the static IP and Google Compute instance. This will create a compute instance VM. Let's change the name. This will be created in Central 1A zone. And here is the image reference. Let's go to the slide deck back and let's copy this. So instead of this hard-coded value, we will use the link generated by compute image. So let's information about the Google Compute image will be found into the GCP documentation here. If you go down here, Google Cloud Platform data sources, here is the Google Compute image. In that you can see here these are the arguments which needs to be provided, and these are the attributes which are returned by this query. So we'll use the self-link URI. So in this case, this compute instance must be created with Ubuntu image. which we have provided here, this information. Now if we try to create this one, because I am in a new directory, I should run Terraform init. Terraform init is successful. Let's run Terraform plan. Oh, this should be prefixed with data. Here we go. So here you can see that the image of the VM has been picked up by the query. This is the version of the Ubuntu will be applied to this VM. Let's run Terraform apply. Let's say yes to this. So this image is getting created. Okay, this is done. And if I go inside this image, and here we can see that this is the image which has been applied. So that's how we use the data sources. If I want to get value of network IP of the VM, I can go and do that as well. Before I do that, let's clean up this image. Okay, this image has been deleted. So let's try creating another data source here. So this time what we will do is we will create data source where the value will be generated after we do the Terraform apply. So for that we will pick up the IP address of this instance after this instance has been created. So let's try that. So to do that, let's have a look into the documentation. So here Google Compute instance under the Google Cloud Platform data source. So I'm looking at this documentation here. So argument where to provide these values. I'm going to provide the self link. So let's pick up this one, resource name from the documentation. And I am going to provide this value, self link. So this data source will return me the entire instance with this link. Now I'm going to print this one. To get the IP address, let's look into the documentation again. So let's use this value. This will give us the external IP. This looks fine to me. This data source will pick up this particular instance, and this output block will give us the IP address from this data source. So let's go and try that. Okay, before I try this, I just want to let you know offline I have just commented this static IP which I was creating so that it generates the dynamic IP. Let's go ahead and try that. Okay, so it's picking up this image, and output which I have defined here will be generated after this instance has been created. So let's try that. Okay, so here we go. This resource has been created, and if you see here, the IP address has been printed here, which we printed through this data source filter from here. So that's it all about the data sources. Let's go to the next topic. Let's talk about the count feature of the Terraform. Generally, when you create a resource using configuration code like resource Google create instance, it will create one resource as you define. But if you need to create the multiple resources of the same kind, you can use Terraform feature count or for each meta arguments. To do that, you can use keyword count. and assign a number to this. This will iterate through the resource and create the number of resources. For example, in this code, we have assigned value 4 to the count. This will create 4 compute instance VMs. But if count value is set to 0, this resource will not be created. Each index of the count can be accessed through a keyword index. That means count.index. Note, count and for each cannot be used in the same block. Also, count value must be known before Terraform apply is executed. That means count cannot refer to any resource attributes that aren't known until after the configuration is applied. So let's do this experiment. Let's clean up. While this is getting deleted, let's create another directory. Count. So let's the code which we created earlier, and we will do the cleanup. This is the count, create a new file. Let's do the cleanup here. So what I'm going to do, I will provide a count here. Say count is equal to 4. So this is going to create 4 VM instances. But we have to take care, like we cannot give the same name of the VM. So let's make this change. I will pass the count as a variable here. As I explained, index will increase one after another for this count. And this looks fine, but we need to copy a file from the common. So this file, as I explained earlier also, it contains the service account and the project name into the GCP. As this is a new directory, we run the Terraform init. Let's run Terraform plan. Okay, I can't use this one as I have deleted the data block. Let's do this. Let's copy this block. Let's have this. Okay, you can see here it is saying that it will add the 4 resources, and if I go up, you can see this default 3, and then 2, and 1, and then 0. So all 4 instances will get created. So let's try this. The first one has been created. So all have been created. So you can see that all 4 instances has been created here. I don't want to start with 0, so what I can do here, I can say plus 1. So it will start from 1 instead of 0. Let's wait it to be deleted. Okay, all have been deleted. So I have added an index here plus 1 so that it will start creating from 1. Okay, let's apply. So you can see here it is started from 1, 2, and 3, 4. So all the 4 instances are getting created. That's it guys for the count. Let's go to the next topic. So we'll talk about the for each and each function. As we talked about in the count metadata description, that for each metadata also used for creating the multiple resources of same kind. For each metadata argument need to be assigned as a map or a set type. For example, in this code we have assigned a map for each which has 2 key value pairs in it. So This resource block will iterate 2 times, one for each key value pair. For each has an object called each, and this object has 2 attributes, key and value. When resource iterate through for each map, the current value is stored in the object each, and if we use each.key, it will return the value of current key, and same way each.value will return the value, and this can be used to modify each resource based in the map element. Same as count, for each value also must be known before the Terraform apply is executed. In this example, we have created a variable called mySet, and which is the type of the set, and this variable has been assigned to for each metadata. But if you have the values in the list format, that also can be used for the for each metadata. Just convert it to the set format using the function called toSet. Okay, let's do the hands-on. Let's do the cleanup first. We will create a new directory for this, and we will copy the common variable. Let's copy the same code again. So instead of count, we are going to use the for each. Let's copy the same thing from the deck. Instead of count, we will use each. So each is the object which is generated by the for each metadata. It will contain the current object when it is iterate through all these values. So as you can see, in the for each we have the two data, key1, key2, which contains the dev and the QA. So when it will iterate through, it will create these two VMs, and the first VM name will be for each test dash dev, and the second will have the QA. So let's run Terraform init. Let's run Terraform plan. And as you say, two resources will be added, and here it is referenced as the key2, and the first one is the key1. Let's apply. Let's say yes. Here you see that two instances are getting created, one with the dev and second with the QA. And this has been completed as we defined here. Like in the for each metadata, we have the dev and QA. Same has been created here with this name. That's it about the for each. Let's go to the next topic. So next topic is a dynamic feature. So within a resource, if you have a block of argument which is repeating, you can use dynamic block for that to make it repeating block. Here in this example, this code is to create the Postgres database. An authorized network block is to add IP address or CIDR of the network allowed to access this database. As you can see in this code, authorized network block is repeating 2 times. This can be changed using dynamic block in the code displayed in the next slide. This is the code where we have implemented dynamic block here for the authorized network. This block will iterate 4 times instead of 2 times we were talking in previous slide, because for each metadata is getting the value from the compute instance.app, and this compute instance.app resource is defined to have count value of 4. So when this compute instance is getting created, it will be created 4 times, and those instance numbers has been supplied to for each. That's why this block will iterate 4 times. The label of dynamic block authorized network in our example specifies what kind of nested block to generate. Dynamic block has following arguments: for each, iterator, content, and labels. For each argument is repeated over map or set provided. Iterator argument is optional. If it is assigned, it represents the current value of the element. But if it is not assigned, it will pick label as default iterator. In our example, if we would not have assigned iterator is equal to apps, it would have considered iterator is equal to authorized networks. Content is the block which defines the body of generated block. Labels. The labels argument is a list of string that specifies the block label in order to use for each generated block. Let's do the hands-on. Let's create a new directory for this. Let's copy the variable. Let's go to the code. We'll create a new file main.tf. We'll copy the provider block. We'll copy the code from the slide deck here. So this block will generate the Postgres database instance. So we will create a compute instance block also. Let's copy from the count. And it is using dataset block. So let's copy this as well. So this database instance block has the block called settings inside. Underneath it has another block called authorized networks. And in this authorized networks, we have a for each metadata which is taking the value of the compute instance apps actually. And here's the issue. So we should have this name as the apps here. So this compute instance count defined as 4 times, it will iterate 4 times, and in the iterator we have defined apps value here, so it will iterate through the apps instead of iterating through the authorized network. So it will iterate through the apps here. This is the content block. Inside that, whatever the value has to come in the authorized network, those has been defined here, and name has been defined as whatever the name of the instance, and the value is the IP address. From this apps reference, it will get the external IP of the instance, and expiration time is some random date and time it is given here. So this dynamic block will be created 4 times in this database instance. So let's try this. Okay, this is fine. Okay, you can see that 5 resources has to be added. So here is the Postgres instance, and these are the 4 instances of the compute instance. And if you see here, this authorized network has been added 4 times here. And the value, which is the IP address, will be known after we run the Terraform apply. Let's run this. Okay, looks like API has not been enabled. Okay, API has been enabled now. So let's try this again. This time it is adding only 1 resource because VMs has been already created. You can see this, it is creating only Postgres database instance. And there is a change here. Now you can see the IP address has been assigned because those instances has been already created. So these IPs has been assigned here. So let's go and create it. Okay, the Postgres database has been created. And you can see here like authorized network is the VMs which we have added in the configuration. They have been added here. and these are our instances, and their IP address has been added here. So that's how we use dynamic block. One sample example is given here again for your reference. If we don't provide the iterator, which we provided in our block here, the iterator is equal to apps, which is taking the reference of this instance. But in this example, we have not provided any iterator, so it is going to take this value, which is the label of the dynamic block, as a iterator, and all the values will be picked from this object. That's it, guys. So we have covered many things. Please go through and let me know if you have any questions. Thank you.